Algebra 1 EOC Star Review on page 18, solving quadratics. The first method of solving we're going to look at is solving by graphing. Here we have two parabolas. We can simply put stars where the solutions are. We know the solutions are found where the parabola crosses the x-axis. So the first parabola has two solutions because it crosses the x-axis in two locations, and the same thing for the second parabola. It crosses the parabola in two places, so there are two solutions. Remember the other words they could use in place of solutions: roots, zeros, and x-intercepts. All four of these are meaning the same thing. So we're going to look at solve by factoring. When we solve by factoring, the first one we notice is already factored. It's 2x times x minus 3. We can't factor x minus 3 any further. There's no GCF, for instance. It's not a difference of two squares. So therefore, since it's already in factored form, we will set each factor equal to 0. So we would say 2x is equal to 0 and x minus 3. From here, all we have to do is solve each of the equations for the variable x, or get x by itself. So on the left equation, 2x equals 0, I would draw a line down the equal sign and then divide both sides by 2 to get x equals 0. There was my first solution. The second equation, I would simply add 3 to both sides, do the opposite, to get x equals 3. So this quadratic has two solutions at 0 and 3. The second quadratic, y equals 2x minus 5, x plus 4 times x plus 4, is also in factored form. I can't pull out a GCF or anything like that, so I'm going to set each factor equal to 0. We're going to solve both for x, so we would add 5 to both sides. This is a two-step equation, so I'm left with 2x equals 5. X isn't quite by itself. My last step is to divide both sides by 2 to get x equals 5/2, or 2.5 as a decimal. The second equation, x plus 4 equal to 0, we would just have to subtract 4 on both sides to get x equals -4. So this one as well has two solutions, or two roots. We also solved, besides graphing and factoring, we solved by quadratic formula. So this first quadratic, the first step is to make sure it's in standard form, ax squared plus bx plus c, and we have to set it equal to 0. So this first quadratic, notice it's not equal to 0, it's equal to 3. So we need to move all our terms to the left side. So we would simply subtract 3 from both sides, and now we have the quadratic in standard form. And we are ready to identify our a, b, and c value. Our a value, remember, is the coefficient in front of the x squared term. Our b is the coefficient of x, and our c is our constant, or the number by itself. Once you have your a, b, and c, you can simply plug those into your quadratic formula. Then you can plug in the discriminant. Remember, that's everything under the radical or under the square root symbol. Plug the discriminant into your calculator. So here you would type in 2 squared minus 4 times 5 times -3 to get 64. Remember, in the quadratic formula, we have to check the plus or the minus. So in our calculator, we could first do -2 plus the square root of 64 divided by 10. And then we could do -2 minus the square root of 64 divided by 10. Once you've done that, you found two solutions, x equals -1 and 3/5. The second quadratic is set equal to 75. Once again, to get it set equal to 0, I'm going to need to move all my terms to the left side. But this time when I subtract the 75 over, I notice it has a like term of +3. So 3 minus 75 is where we get the -72. If I could identify my a, b, and c, my a, remember, coefficient of x squared is 8. Notice there is no x term in the middle here like we had on the previous problem. So our b term we would identify as the value 0. And then c term is the -72. Once you've identified a, b, and c, we can simply plug those values into the quadratic formula. And we're ready to calculate the discriminant, or what's under the square root. Using our graphing calculator, you should get the value 2,304. So you'll type in two things. Using alpha y equals 1 in your calculator, you'll do 0 plus the square root of 2,304 divided by 16. And then alpha y equals 1 again, and then you could do 0 minus the square root of 2,304 divided by 16. You should find two solutions, at positive and at -3.